So another round, and this time we're going to have to bust out our calculators. You'll see why in a moment, which just adds a new element to all this. But the same trick is going to be used, the same ideas, the same concepts. We're going to have to employ technology. So this first one looks pretty simple, right? Because I do have a linear function in terms of sine, and I know it's the double angle, but we've learned how we can solve that. So if we subtract 3 and divide by 5, we eventually end up with sine of 2 theta is equal to negative 3 over 5. And so in this case, as far as sine is concerned and the angle involved, this is not a nice, neat ratio. So let me go ahead and let me rewrite this as the sine of beta is equal to negative 3 over 5. And what we're going to have to do is use our inverse sine. Okay? Now here's where we have to be careful, because I'm looking for solutions in the first positive revolution, and we know that when I invoke the inverse sine function, that is limited between negative 90 to 90, and it's negative. So I'm anticipating getting a quad 4 negative rotation angle in there, and we're going to have to work around that to get us back to 0 and 360. So going to my technology, let me bust out my Desmos here. Let me find it on my phone. Right, so going to my Desmos, let me clear out the work I was doing there. What we're looking at here is the inverse sine function, and we're in degree mode. The inverse sine function of negative 3 over 5. So what I'm getting is a negative 36. It looks like 86.99 if we round off to 3 decimals. So that's telling us that our beta is negative 36.8699 in degrees. So the good news is I have a value that works. The bad news is it's not in the what I want. But what we'll do is we'll just make sure we'll use our idea of reference angles. So what we basically have picture-wise is right now my solution, right, is rotated negatively, negative 36.8699. So what I have in terms of my angles involved, I've got 2 of them, right? I'm going to have the same reference angle, right, because, where sine's negative in this quadrant and in this quadrant. So what I have is I have the same reference angle, 86.99 here. So to find this angle, we basically need to go 180 plus it, and then to find this angle, I need to go 360 minus it. So one of my angles is 180 plus 36.8699. That's going to give us the quad 3 angle, and the quad 4 angle, our beta is 360 minus 36.8699. So here what we get, this one I think I can do is 216. So 216.8699. And this one, let me go ahead and say we've got 360 plus that. 323.1301 degrees. All right, so that is just in my first rev. So what we know then is my 2 theta, right, is 216.8699, right, comma 323.1301 degrees, and this is in the first revolution. But since my period has changed, right, it's going from 2 pi to pi, that means we actually have to go a second revolution out. So just add 360 to this. So if I take If I take 360 and add 216.8699, then what we get is 576.8699. And if I add 360 to that, we get 323.1301, right? Which is 683.1301. So there's my solutions in all those revolutions. So of course, to find theta, I have to multiply by a half, which means everybody gets multiplied by a half. So our theta values essentially is taking all these guys and dividing them by 2. So let me just go ahead and clear that out, and I'll start fresh. So we have 216.8699. We're going to divide that by 2, and that gives us 108. It looks like 4350, right, if I round off. So that falls within that data range. If I take the 323, .1301, right, that gives us 161 point, it looks like 5651, right? So that also falls within what I want. If I now take the next angle, 576.8699, we get 288.4350. And then last but not least, if we take the 683.1301, we get 341. That's a 341.5651. So you can see our trick again worked. It should work. All these angles fall within the first positive rotation from 0 to 360. And we're off to the races and we're going. So that one was tough because we had a ratio. It started off easy enough, but we had a ratio that wasn't common. So I needed to invoke my calculator, and then I needed to invoke my reference angle idea to get me within the first rotation. And then to account for the fact that the period is compressing, I had to go a couple revolutions out, which is just we just use coterminality. In this case, add 360 to get it. Divide everybody by 2, and we basically come back to all my solutions that I need. And again, we're good to go. All right, so that took almost 8 minutes. So I've got another one. You can already see. Let me go ahead and start it. If we add and subtract, we get that the cosine squared of 3 theta, right, is 4/7. And so again, that's not a nice common ratio. If I took a square root, we get that the cosine of 3 theta is plus or minus 2 over the square root of 7. And I'm just going to leave it at that rather than rationalizing it. So because of the plus minus, we're expecting solutions in all 4 quadrants, right? But because of the not nice ratio, we got to invoke our calculator and then our reference angle, and then, right, we got to go out 3 revolutions because our new period is 2 pi over 3. So there's a lot of work in this guy. So there's the initial setup. But let me go ahead and I'll cut away to a new video where we finish that up because I'm already almost 10 minutes into this one. So I'll be right back to wrap that one up because we've got